Case study: Enhancing Cybersecurity Resilience, Technova's multifaceted approach to threat mitigation and AI integration. Technology giant Technova faced a significant cybersecurity breach when an advanced persistent threat infiltrated their network. This breach highlighted vulnerabilities in their existing security infrastructure and underscored the need for comprehensive cybersecurity measures. Technova, a leader in software development, held sensitive information, including proprietary code, customer data, and financial records. The attackers, exploiting a zero-day vulnerability in one of their applications, managed to gain unauthorized access and remained undetected for several months. Andrew, head of the cybersecurity division at Technova, convened an emergency meeting with his team to assess the damage and formulate a response strategy. How did this happen, and why did our existing measures fail to detect the intrusion? Andrew asked, setting the tone for a detailed post-mortem analysis. The team began by categorizing the threat vectors involved in the breach. One of the primary vectors identified was a phishing attack that targeted Technova's employees, tricking them into revealing their login credentials. This enabled the attackers to bypass initial security barriers. The team recognized the importance of multi-factor authentication in preventing such breaches. What specific steps can we take to enhance our MFA implementation to make it more effective? Andrew inquired. The consensus was that MFA should be mandatory for all employees and integrated with behavioral analytics to detect anomalies in user behavior. Upon further investigation, the team discovered that the attackers had used a combination of SQL injection techniques to manipulate the back-end database and gain deeper network access. This raised a critical question. How can we bolster our application security to prevent SQL injection attacks? The solution lay in adopting secure coding practices, implementing robust input validation, and regularly conducting code reviews and penetration tests to identify and address vulnerabilities before they could be exploited. Another significant finding was the insufficient network segmentation, which allowed the attackers to move laterally across the network once they gained access. What measures should we implement to improve network segmentation and restrict lateral movement? Andrew queried. The team proposed deploying microsegmentation, a practice that divides the network into smaller, isolated segments to contain breaches and prevent attackers from moving freely within the network. This approach, coupled with the use of next-generation firewalls and intrusion detection systems, would enhance network security. One of the most concerning aspects of the breach was the attacker's ability to remain undetected for an extended period. This highlighted the need for advanced threat detection capabilities. Can we leverage artificial intelligence to improve our threat detection and response times? Andrew asked, pointing to the growing role of AI in cybersecurity. The team agreed that AI-powered systems could analyze vast amounts of data in real time, identify patterns and anomalies, and predict potential attacks. This would enable Technova to detect and respond to threats more swiftly and effectively. To illustrate the potential of AI in enhancing cybersecurity, the team examined a case study where an AI-powered security system successfully thwarted a sophisticated malware attack. The system analyzed network traffic and identified unusual patterns that indicated malicious activity. By correlating data from various sources, the AI system provided a comprehensive view of the threat landscape and automated the response to mitigate the attack before it could cause significant damage. This example underscored the potential benefits of integrating AI into Technova's cybersecurity strategy. However, the integration of AI was not without challenges. The team recognized that AI systems could be exploited by attackers through adversarial machine learning techniques, where manipulated inputs could cause the AI to produce incorrect outputs. Andrew posed a critical question. How can we safeguard our AI systems against adversarial attacks? The team recommended implementing robust adversarial training, where AI models are exposed to manipulated data during the training phase to improve their resilience against such attacks. Additionally, continuous monitoring and updating of AI models would be essential to maintain their effectiveness. Another challenge identified was the dependency on high-quality data for training AI models. Poor quality or insufficient data could lead to inaccurate predictions and ineffective threat detection. What strategies can we adopt to ensure the availability of high-quality data for our AI systems? Andrew asked. The team suggested leveraging diverse data sources, such as threat feeds, security logs, and social media, to enrich the data pool. They also recommended implementing data preprocessing techniques to clean and normalize the data, ensuring its suitability for training AI models. The significant investment required for AI integration was another concern. Technova needed to invest in high-performance computing resources and skilled professionals to develop and manage AI-powered security solutions. How can we justify this investment to the executive board given the current budget constraints? Andrew inquired. The team's response was to present a cost-benefit analysis demonstrating how AI could lower the cost of detecting and responding to breaches, thereby reducing the overall financial impact of cyber attacks. They also proposed a phased implementation approach, starting with pilot projects to showcase the effectiveness of AI in improving cybersecurity. As the meeting concluded, Andrew summarized the action plan. The immediate steps included enhancing MFA implementation, adopting secure coding practices, improving network segmentation, and integrating AI for advanced threat detection. The team also emphasized the importance of continuous monitoring, regular security assessments, and employee training to maintain a robust cybersecurity posture. In the aftermath of the breach, Technova implemented the proposed measures and saw a significant improvement in their cybersecurity resilience. The introduction of AI-powered systems enabled them to detect and respond to threats more efficiently, reducing the time to mitigate attacks and minimizing potential damage. The adoption of secure coding practices and network segmentation further strengthened their defenses against cyber threats. Reflecting on the experience, Andrew emphasized the need for continuous improvement and adaptation in cybersecurity strategies. He noted that the evolving nature of cyber threats required organizations to stay ahead by leveraging emerging technologies and adopting proactive measures. What lessons have we learned from this breach, and how can we apply them to future cybersecurity initiatives? Andrew asked the team, encouraging a culture of continuous learning and improvement. The team's response highlighted several key lessons: the importance of a multi-layered security approach, the value of leveraging AI for advanced threat detection, and the need for regular security assessments and employee training. They also recognized the significance of collaboration and information sharing with other organizations to stay informed about emerging threats and best practices. In conclusion, Technova's experience underscores the critical importance of robust cybersecurity measures in protecting systems, networks, and data from a wide range of cyber threats. By implementing a multifaceted approach that includes secure coding practices, network segmentation, and AI-powered threat detection, organizations can significantly enhance their cybersecurity resilience. Continuous improvement and adaptation of cybersecurity strategies, along with a culture of learning and collaboration, are essential to staying ahead in the ever-evolving threat landscape.